Hello, this is Mr. Stansbury. I'm going to take you through the notes on Vertex. Okay, at the end of this, you should be able to say I can find the vertex of a quadratic function and use it to find the domain and range. Okay? All right, so let's just head straight into some examples here. Find the coordinates of the vertex of this here. Now, big thing that's important on this is just in the previous section we talked about the axis of symmetry. So axis of symmetry is x equals negative b over 2a, right? So we're going to use that to find the x coordinate. Once we know the x coordinate, we'll plug it back in to find the y coordinate. All right? So let's see. A is negative 2. B is positive 6. And we don't even need c, but c would be negative 3. Okay? So in this case here, we get x equals negative 6 over 2 times negative 2. So that gives us negative 6 over negative 4, which is 1.5. So there's our x coordinate. Okay, or you can put it as 3/2 or 1.5, whichever one you want. Okay, now that we know the x coordinate, we can plug this x coordinate here into the original equation and find y. So we have y equals negative 2x squared plus 6x minus 3. So now we'll do y equals negative 2 times 1.5 squared plus 6 times 1.5 minus 3. Okay, so that's not super pleasant. It's doable, but it's not a great one to square. But let's just put on the graphing calculator. We'll do 1.5 squared. Super important, if this was negative, if you're going to do it on your calculator, you want to put parentheses around it. Otherwise, if you don't, you'll end up getting a negative number for that, and we know that when you square a negative number, you're going to get a positive. Okay, so on this one here, 1.5 squared is 2.25. Times that by 2, and we get 4.5 plus 6 times 1.5 is 9 minus 3. So our y coordinate is going to be 4.5 plus 9 is what? 13.5 minus 3 is 10.5. So we end up finding the coordinates of the vertex to be 1.5 and 10.5. Okie dokie. Okay. Example 14. This is actually our second and last example. So let's do a few of these parts here, and then we'll do a little comedy break here in the middle. Okay, consider the function y equals blah 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 blah. Find the axes intercepts. So if we are going to say for a, find the x intercepts, remember that y equals 0. So we will do 0 equals 2 times x minus 3 times x plus 1. And this is nice here. This 2, if there was an x here, that would mean that one of our zeros, or x-intercepts, would be at 0, but there's not an x there, so that just 2 doesn't even affect anything here. And then we set each one of these equal to 0, right? What minus 3 gives us 0? Positive 3. What plus 1 gives us 0? Negative 1. So the x-intercepts are at 3 and negative 1. Okay, and I'm just going to kind of ahead of time here on part D. It says sketch the function with all the important features, so let's graph these things as we get them. So we got an x-intercept here at 3 and also at negative 1. Y-intercept is, remember, when x equals 0. So we get y equals 2 times 0 minus 3 times 0 plus 1. So we get y equals 2 times negative 3 times 1. So 2 times negative 3 is negative 6 times 1 is still negative 6. So let's even do this. Let's do y intercept equals negative 6. So now we are down here for the y intercept. Okay, so we are getting somewhere here. All right, let's take our quick little comedy break here. Oops. Come on, play. There we go.
Tennis is weird. The scoring system per game in tennis is mathematically ludicrous. It doesn't make even a little bit of sense. First of all, there's no 0. If you don't have any points, you have to say love. If you don't say it like that, your opponent gets upset for some reason. How many points do you have, Brian? I think you know. I've never touched the ball ever. I have 0. You have love. It don't feel like it.
All right. B, find the equation of the AOS, axis of symmetry, right? So for B here, that's x equals negative b over 2a, right? Now, here's the interesting thing here. This is not in the form that we can figure this out, so we are going to actually want to multiply this out. So we get y equals, let's just FOIL this part here first. So we got 2 times x is x squared. X times 1 is plus x. Negative 3 times x is minus 3x. And negative 3 times 1 is negative 3. So we get y equals, let's see, 2x squared. I'm going to kind of combine 2 steps here. X minus 3x is negative 2x times 2 is minus 4x. And then 2 times negative 3 is negative 6. So our axis of symmetry here is going to be, here's our A and here's our B, right? So we get x equals negative 4 over 2 times 2. So this is negative 4 over 4. So our x, axis of symmetry is x equals negative 1. Something looks fishy here because it should be right here at positive 1, right? All right, what did Mr. Stansbury mess up here? Oh, I forgot the second negative because it's negative 4, so that's plus 4, so that's plus 1. It's the nice part about us already graphing this is we kind of get an idea. We know it's going to be halfway in between those two, right? So here is our axis of symmetry right down this x equals 1 line. We know it can't be at negative 1 because that's where one of our intercepts is. Okay. C, find the coordinates of the vertex. Okay, so now that we know what x is, now we can plug that x into the original or our new one. I'm going to plug it into the original just because then I know in case I made some kind of mistake here, I know for sure that that equation is right. So let's do this. Y equals 2 times 1 minus 3 times 1 plus 1. So y equals, let's see, 2 times negative 2 times positive 2. So we got 2 times 2 times 2 is 8, and a positive times a positive is negative. So the coordinates of the vertex are going to be at 1, because we know the x is at 1, and then the y is negative 8. So now we're at 1, negative 8, which that looks like that's pretty good, because that looks like that's going a nice little curve there. Okay. D, sketch the function with all the important features. So now we have this here. Oh, this is going to be the challenging part for me, is to trying to draw this. I know that this is going to reflect us straight over here. So this one looks kind of like that. That one's not bad. And this one, close enough. You get the idea. Okay. Again, it does say sketch, so that means as long as it's somewhat close. Okay. Now, last part. Find domain and range. So that's what remember, domain is what the x's can be, and range is what the y's can be. So domain is what can the x's be, right? And then the range is going to be what can the y's be. Okay, so let's do this for domain. Our domain, if you look here, the x, it's like this arrow here is pointing up, and it's still moving to the left ever so slightly, but it's always moving to the left. So that means it goes forever and ever to the left. And then also, so it goes like this, it's going forever and ever to the right. So the domain on this thing is going to be all real numbers. Okay. Pretty much all of these here, since they're all going to be going to the right and to the left, they're all going to be, domain should always be all real numbers. Okay. Range is what the y's can be, right? What the y's can be. Okay. So that is the range. So if you'll notice here, we have a minimum right down here. And the lowest the y value ever gets here is -8, right? And then it just gets bigger from there up. So I can say x is going to have to be bigger than or equal to negative, oh, not x because it's range, sorry. That should be y is greater than or equal to -8. Okay, so that's all the y's. Everything up here in the 8 millions or whatever, this graph would eventually get up there. Okay? Okay, that's all we have for Vertex. If you have any further questions, please feel free to ask. Thanks.